Good afternoon, everyone. My name is Carlos. I'm a web developer based in Brooklyn, New York. And today we're going to work on a project called Supernatural Inheritance, where we'll be learning a little bit more about inheritance with C Sharp. So a few key concepts. In order to complete this project, you should be familiar with classes and objects, how to create a class, how to instantiate an instance from the class. You should also be able to know how to work with arrays and work with iterating over arrays and values. And lastly, we're going to be using inheritance, so you should be at least familiar with inheritance and using certain keywords like base or virtual and override in order to actually pass in methods from a subclass to a derived class. So without further ado, let's go ahead and get started. Okay, so for this project, we're at the Codecademy Guild of the Supernatural, and there will be 3 ranks of magicians. They're going to be ranking from the least powerful to the most powerful. That's pupil, mages, archmages. So in this project, we're going to be developing a system in C# to track the weather magicians and the guilds and their spells. So first we're going to have some empty files here. You can look at the directory icon here to see what files we have exactly. We'll be focusing mostly on the ones that are opened up here. If you close one, you can simply just open the directory folder and reopen that file again. So we're going to be working mostly in the pupil, archmage, mage, and storm classes or files that we have here that are all currently empty, and then running all of our code here in the program.cs file. So let's take a look at what exactly we need to do and get to know a little bit more about the pupils and the other classes. So pupils have a title and can create one weak windstorm. Mages have a title and can create a weak windstorm and a weak rainstorm. And archmages have a title and can create a weak windstorm, a strong rainstorm, and a strong lightning storm. So you can see how there's already some sort of sharing between these ranks. Certain kind of storms are being shared by all of them, and they all seem to have a title as well. So notice anything shared in these ranks. If we created a class for each type of magician, we would have a lot of duplicated code. So for example, every magician has a title and a windstorm. So we're going to be using an inheritance to actually avoid duplication. So you can see pupil is the base class, which will be the least powerful wizard. Then mage will inherit certain things from the pupil, and the archmage inherit things from the mage, which by itself inherits from the pupil. So you can see how there's like certain properties and probably a method that's being passed down all the way from the weakest, most superclass, all the way down to the archmage. We're also going to need a storm class in order to actually create the storm, which stores the essence, the strength, and the title of the magician that we created, who created it. So let's go ahead and start with our first step here. For our first step, we're going to be defining the storm class. So let's go to our storm.cs file, and we'll create an empty class named storm. So that is simply by using the keyword class, call it storm, and open up our code block. So this is for step 1. For step number 2, we're going to define 3 automatic properties. Each one should have a public getter and a private setter. We're going to use a private setter so we can actually define, we can set the value of these properties within this class itself. So let's go ahead and write public. We'll specify the data type, which is a string, and we'll call this essence. And here we'll use a shortcut to create a getter and a private setter. We're going to be doing the same for our other 2 properties. One is a boolean called isStrong. We'll set our getter and our private setter as well. And lastly, we'll create our string caster, public string caster, with our getter and our private setter. Okay, let's go ahead and save that. I would suggest you guys save consistently throughout every few steps just to make sure there no errors pop up on your terminal here. So I'm going to expand the code editor and bring up the instructions again. We'll continue to step 3. Now in step 3, we're going to define a constructor that takes 3 arguments, one for each property, and in the body of this constructor, we're going to use those arguments to set the property values. So we're going to write our public method here, constructor here. We're going to name it the same as a class. And in here, we're going to pass in the parameters, which are going to be set to the properties in the code block. So we also have to specify the data type. So we're going to start by specifying data type for essence. Then we're going to specify the boolean for isStrong. And notice that I'm using camel case here to differentiate the title of the property between the parameter. This could, in a sense, be anything you like. This is just a parameter name. We're just using it the same as the actual property, just so it knows what to set the value to. It's a little bit more readable and it makes sense to anyone else reading your code. So we'll specify the caster, and in here in this code block, we're going to set those arguments to the property values. So right now when we instantiate an object from the class storm, we need to set those properties, which are set up over here, to the values that are passed in when we create an instance of this class. So how do we set the properties? Well, we specify what are we setting and what are we setting it to, which will be the value that's passed in as an argument. We'll do the same for isStrong equals isStrong, and then caster, the property of caster will be equal to caster. So just in order to make sense, when we create a new storm, for example, we'll call it S. This is the instantiating. This is basically what is passed into the constructor. So here is where we'll specify what kind of values are being passed in. So this could be whatever, ASDF, just as long as we set the same kind of parameter name to the value that we're setting it up to. So for more readability, I'm just calling it essence, and I'm making sure it's not a capital E, because then it will read it as a property name and then it will cause an error. So let's go ahead and save this, make sure there's no errors in our code, and it seems to be fine. Then we can move on to step number 4. Expand this again. Okay, so now we need a way to print a storm object to the console. So we're going to define a public announce method that returns a string, and the string should use all 3 properties. For example, if a weak windstorm is casted by Zul Rajaz, the string would be as follows here. Okay, so let's go ahead and write our method. I'm going to make a little bit more space here so you guys can see. Make sure you're nesting this within the class code block. A lot of people tend to put it outside and that causes errors. So make sure you're nesting this inside the class code block. So let's make our method announce. What is it going to return? It will return a string. So we got to specify what kind of data type it's going to be returning. We'll open up our code block. Since it's not receiving any parameters, it's just returning a string. We don't need to put anything inside the parentheses there. So we can simply print out the string using the properties and interpolation. The only problem here is that there's no coercion for booleans. We can't really translate false to, if we print is strong, it won't really coerce that into a string. Because right now string is a boolean, is strong is a boolean that returns true or false. So we have to specify if is strong is true, then the keyword we'll be printing out will be strong. And if it's false, then we're going to be printing out weak. So we can set that up in an if-else statement. So what is the expression, the conditional that we're trying to check? We want to check if is strong is true. And we can basically make that into a shortcut by just simply typing in is strong, is strong. So if this is true, this code block will be executed. If it's not true, implying that it's false, then this code block will be executed. So here we can actually interpolate the other properties, which are the caster, cast weak. In this case, for this code block, since is strong is true, we'll replace weak with strong, and then the essence of what we're actually casting. So here we can simply return a string using interpolation. We're going to say the caster, which is the name of the person who's casting this, the storm, cast strong essence storm, and don't forget your semicolon. Otherwise, if it is strong is false, we'll return basically the same thing, except we're going to specify that it's a weak storm. So caster cast weak essence storm. Okay, let's go ahead and save that. Make sure there are no errors in our code here. And there seems to be an error here. The reason I'm getting this error is because I'm not using Pascal case here. Right now I'm referencing the parameter, I guess, that's here, which doesn't exist in the class itself. We have to access the property. So we need to use the property of capital I is strong. Remember, this is the actual property of an instance of the class. So we save this. That should solve our issue here. And that seems to be good to go now. Okay, let's open up our instructions and move on to step number 5. So now we can actually test our class in our program.cs file. So let's go to our program.cs file and we're going to construct a new instance of our storm class. So we got to specify what kind of value is this, what data type it is. We know it's of the class storm. We're going to call it S, and we'll create a new storm. We want it to have the essence of wind. We want it to be false, and we want it to have the name of Sul Rajas. Remember, these have to be in the same order you have defined them in your constructor. So if you put them in a different order, like you see here, if you put the Boolean first and then the caster second, it will give you an error because it's expecting a string as the first parameter. You can obviously set default values and there's ways around it, but just to keep in mind, this should be the same order as you have it in the constructor there. So now that we have our instance of the class storm, we can simply call the announce method. Now, there's a problem here because .announce is not really going to write anything to the terminal. If I call it here, nothing will be printed because all this is doing is just returning us a value of a string. We're not really printing on the terminal. We could essentially print it out from here, but what we want to do instead is let's just console write from here. So the return value of this call is a string. So what we're doing is we're console writing the value from this method call. So let's go ahead and save this, and this should print out Solar has cast a weak windstorm. Okay, that looks good. That's it for our storm class. We're going to be working with our pupil class and be defining some stuff to be passed into other subclasses. So let's go ahead and open up this terminal, the code editor again, and we'll start with step number 6. Okay, now we're defined the pupil class. So let's go to our pupil class here. In the pupil CS, we're going to define a class named pupil with 2 members, a string title with a public getter and private setter. This represents the name of the pupil, and a constructor with one argument that sets the title property. So similar to what we did in Storm, we're going to set our properties here. So we're going to specify it as public. We're going to know that it's a string that's going to be set to title. We'll set our shortcuts for the getter and the private setter so we can define it within the class. And then, I'm going a little ahead of myself here. We have to actually specify the class pupil. And inside here, we'll put our code for the property and the constructor. Let me just correct some of the spacing here. There we go. Now we can set up the pupil constructor here, which will take in a string as title and set the property of title to the string that's being passed in. So just for sakes of sanity, I tend to just save this to see if there are any errors. That's just the line from the program.cs file. It seems to be good, so I'll expand the editor again and we can move on to step 7. Okay, now we need to give the pupil its single spell. It's called a cast windstorm method, and it should be a public with return type storm. And in the body of the method, we're going to construct a new storm object and return it. Okay, so let's go ahead and in our class, we're going to set up our method here. We know that it's going to be returning a data type storm, so we can specify that before the actual name of the method. And the method will be called cast wind storm. Doesn't take any arguments. We'll set up our code block here. And here we can just simply return a new instance of our class storm. We know that it's going to be of essence wind. We know that it's going to be weak. And we wanted to use the title of the pupil that's created. So how do we actually access the title? Well, we can simply pass in the property from inside the method, because this method will have access to the value of the property of that instance. So now we can actually save this, make sure there's no errors. Looks good. And then we can move on to step number 8, where we're going to be testing if we can actually create a storm from this pupil. So in step number 8, we're going to test our class. So in program.cs, we're going to construct a new pupil named Measle-Cree, and then we're going to construct a new object and then call cast windstorm and store the result in a variable. So we got to do a few things because we can't simply just call s.announce from a storm created from the pupil. Let's go ahead and comment this out. Actually remove it because we're not going to be using that again. So let's go ahead and create a new pupil. So pupil P equals new pupil, and we're going to pass in the name here. We have Mizzle Cree. Okay. Then we're going to be storing the value of cast windstorm call. So we're going to know it's going to return a storm. So we got to specify the name of where we're going to store it, which is a storm value. We call it windstorm. We'll set it equal to p.cast windstorm. So this returns a storm itself, and if we want to actually print out the weak windstorm, we have to actually call .announce from this storm instance. So remember that cast windstorm from the pupil class simply returns an instance of the class storm. And inside our class storm, we have the actual string that we're going to be announcing. So we have to do what we did before. We have to do console.writeLine windstorm.announce because this instance has access to the method announce. So let's go ahead and open the text editor and see if we're able to announce the storm itself. Mizzle Creek cast a weak windstorm. Okay, great. That seems to be working. Let's go ahead and move on to step number 9, where we're going to be working with a mage. Make some spacing here, guys. Okay, for the next rank, Mage also has a title property and a cast windstorm method. It also has a new cast rainstorm method. Instead of running the first two members again, we can inherit them from pupil. So let's go to mage.cs and define an empty class that inherits from pupil. So we're still going to use our keyword class here. If we want a class to inherit something from a different class, from a superclass, we can specify it using the colon here. So now we have our access to the pupil properties that we can pass into mage. So now that we actually have an empty mage class that inherits from pupil, we can specify what we want to grab from that class. So let's move on to step number 10, where we're going to be doing that. So we're going to be adding a mage constructor with one string argument. It should call the base constructor with that same argument. Okay, so we know that it's going to be inheriting the title from the pupil class. So let's go ahead and write in public mage. This is a constructor. Since we are accessing the title from pupil, we don't actually need to set a property like we're doing here in pupil. We can just simply grab it using the base keyword, which I'll explain what exactly it is in a second. So our constructor will take in our title. And in order to use the base constructor, we need to use a colon and call base, followed by the property that we're actually going to be accessing from pupil. So base is basically kind of like constructor called to the superclass that we're inheriting from. So mage, this constructor here will basically call the constructor from pupil and set the title to the title passed in the argument when you create a new mage. So hopefully that makes sense. So now we have that. We still need to create an empty code block just to make sure that it's a constructor, since we're passing a parameter here. And then we can move on to step number 11. Now we're going to give the mage a new spell called Cast Rainstorm. It should be public with return type storm. And in the body of the method, we're going to construct a new storm object and return it. Remember that this is a weak rainstorm cast by a mage. So we can simply call in here public storm because we know that data type that's going to be returning is a storm. We'll pass the method name, which is called cast rainstorm. And here we'll set up our code block. We'll return a new instance of storm, which is rain essence. It is weak, and it will use the title of the mage that we created it. Okay, let's move on to step number 12. For step number 12, we're going to test our class in program.cs. So go to our program here. If I can find it, let me expand this here. Okay, we're going to construct a new mage named Golden. I'm not sure if I'm pronouncing these correctly, guys, so bear with me. So after constructing a new object, we're going to call cast rainstorm and store the results in a variable. And then we're going to use the same thing we did here where we console writeline the announce method on that storm. So let's call mage, which will be equal to new mage the name of the actual mage. I'm going to pass in rainstorm, and then called, let me rename this for mage, m dot cast rainstorm, and then we'll console.writeLine rainstorm dot announce. So essentially we're doing the same thing we did with our pupil, except we're just casting a different kind of storm from the mage class. So hopefully that allows us to print out the same kind of rainstorm. And there we go. Cooldown cast a week rainstorm. So let's backtrack and go again to our mage. We're simply returning type of essence that it's weak and the title of the actual mage. And the reason we get access to the title here is because we're actually calling the constructor from our pupil class, which sets the value title to the property title to the value passed in the instantiation of the class. So you can see here when instantiating it with the title Gul'dan, Gul'dan is passed in the constructor here, sets the property title to that value, and then in that value, we use the value of that property to pass it down to this method call to create an instance of our class storm. So it's a lot of, you have to kind of go through all the classes to see exactly what is being passed in through, but hopefully it makes sense once you kind of like backtrace and see what exactly is happening. So let's move on to step 13. We're going to be working with our Archmage. For our Archmage, he also has a title property and a cast windstorm method. On top of that, it overrides the cast rainstorm and has a new cast lightning storm method. So instead of writing the first two members again, we can inherit them from mage. So in Archmage, let's go to this file. We're going to create an empty class that inherits from mage. So let's go ahead and create our empty class here. Class Archmage. How do we inherit? We use our colon and we specify what class we're inheriting from. We're inheriting from mage. Okay, that's it for step 13. Let's move on to step 14. For step 14, we're going to add an Archmage constructor with one string argument. It should call the base constructor with that same argument. So what are we grabbing from the Archmage, from the mage class? We're going to be grabbing the title. Let's go ahead and write our constructor here, which is going to be using the same base constructor that we use to grab properties from the superclass, which in this case is mage. So call string title, we use our colon, we call the constructor the keyword base with the same string name. And make sure you add the empty code block, otherwise that will give you errors. So that's it for step 15. Let's go ahead and save this just in case for sakes of sanity. It should be printing out the same lines we have from program.cs. Seems to be good. So let's go to step 15. For here, we're going to overwrite the cast rainstorm. What do you mean by overwriting it? Well, if we look at our superclass from the class we're inheriting properties and methods from, in this case is mage, we have a cast rainstorm already defined here. So if we want to override it and create a new kind of method, we have to actually override it. So just like the one in mage, it should be public with return type storm. So in the body of the method, construct a new storm object and return it. So let's go ahead and start that out first. We know it's going to be data type storm. We're going to call the same method name. And it should return a new storm instance, which will be rain. It's a strong rain. So in this case, the only difference will be that we're using the Boolean set to true in order to create an actual rainstorm that is strong. So they're warning us already that we're going to be seeing an error that we're going to be fixing in the next step. Let's go ahead and save and see what the error says. Archmage cast rainstorm hides inherited member. Use a new keyword if hiding was intended. So one of the errors that we missed is we actually forgot to set up that this method is overriding the method from the class of mage. So let's go ahead and save this again and see if this causes a new kind of error. We cannot override inherited member cast rainstorm because it is not marked virtual, abstract, or override. So if we want to override a method from a class above us, we actually have to specify that this method is expected to be overwritten in, in derived classes. So let's go on to step 16 and see what exactly we need to do in order to fix this error. So since the cast rainstorm method is overwritten, it must be marked virtual in Mage. So let's go ahead and open up Mage. And in here, we have the actual method. We got to specify that we're actually going to be overriding this method. So we can do this by using our keyword virtual. So if you already kind of know that we're going to be redefining a method from a superclass in our subclass, we have to specify that it's going to be overwritten with our keyword virtual. And in our ArcMage class, we have to make sure that we're overriding it. So you have to keep in mind to do those two things if you're going to redefine a method. Let's go ahead and save that and see if we're still getting an error here. And we're good without the error. So let's move on to the next step. Now in step 17, we're going to add one more spell to ArcMage. Let me expand the editor again. We're going to call it Cast Lightning Storm. Just copy this here. It should be public with return type storm, and in the body we're going to passing a new storm object and return it. It's going to be a strong lightning storm cast by the Archmage. So let's write our name here. We know it's a type storm. It's called cast lightning storm. In our code block, we're going to return a new instance of storm. We know it's going to be lightning. Yeah. We know that it's going to be strong, so we'll set the boolean to true, and we'll use the title of our caster here, our Archmage. So I'll save that to make sure there are no errors. Okay, cool. We'll move on to step 18. So now we're going to be testing our Archmage here. We have our pupil, we have our mage. Now let's create our Archmage. So Archmage A is called new Archmage. We want it called Nilas Aran. Set this in quotes. Okay. So now what we need to do is construct a new object by calling cast rainstorm. We already have, I believe, rainstorm from the mage, so we have to use something else. Keep in mind, maybe be a little bit more verbose with your variable names so you don't confuse them. Let's do Archmage storm, rainstorm. Okay, Archmage rainstorm. I know it's a lengthy variable name, but whatever works for you. We'll call cast rainstorm. And I'm also going to call the other storm already. So let's call it Archmage lightning storm a.cast lightning storm. Hopefully there's no spelling mistakes here, guys. And now we can simply call announce on these guys. So console.writeLine. We'll call this Archmage storm. Now that this is a storm instance of the class storm, we have access to our announce method. And then we'll do the same for our other one, Archmage lightning storm. .announce. Still super long variable name. Hopefully we'll see all 5 of them here. 4 of them, I mean. It seems the storm does not contain a definition. Announce. Did I do a spelling mistake here? Let's see. Announce. There we go. So you'll see the line on the errors too. See, now we actually are able to cast all the storms. Let's go back to this error so you guys can see a little bit more clear where exactly it is found. Storm does not contain a definition for announce and no accessible extension method announce. You will see that it's telling us on the first line where exactly this error is. So on line 24 on column 48. So if we go to program CS, we go all the way to line 24, we'll see that the error of the code is found in this specific line, column 48. So you can't really see the columns, but you know, if it's 0, it's probably somewhere here or whatever. So we know that the error is on this line, so we can save that, and that should fix our error here. Awesome. That's it for our project. Hopefully that made a lot of sense. And now we're going to be working with a couple of the extensions we have. So if you've gotten this far, congratulations, tap yourself on the back. But let's go ahead and see how we can actually finish the extensions here so you get a better idea and better comprehension of how inheritance works. Okay, so for our extensions, now that we've finished all our classes, 3 of them are in the inheritance hierarchy. You can see that we're passing Archmage, which is inherited from the Mage, which is inheriting from Pupil. Okay, so each class has at least one method that uses a 4th class, Storm. So if we got a little bit more practice, we have 3 optional challenges here. First one, in program.cs, we're going to store the Storm objects in an array instead of separate variables. So if we're going to be storing a bunch of values of class Storm in an array, we have to specify what kind of values are going to be stored in this array by using our brackets. And we're going to be storing a lot of these cast windstorms in the actual storm array. So in order to create an array of data type storm, we simply have to call storm by using our brackets here. Then we'll label the variable name to storms, and then we'll create a new array of the length 10 of data type storm. So this will essentially be expecting 10 values of the data type storm in them. So that we set up the length, its fixed length is 10. And now we have to specify a storm index, because anytime we actually create a storm and store it in our array here, we have to increase the value of our storm index to ensure that we're passing it into a valid element or value in the array. So we'll specify the storm index as an integer, and we'll call it storms index, I guess, storms index 0. Now we have our pupil, and now instead of just simply creating a storm data type set to the variable windstorm, instead of storing it in the variable here, we can simply call storms index, which is the same as storm 0 because our index is currently at 0, will be equal to the cast windstorm, the windstorm from our pupil class. So now we can actually get rid of our console write line here, because what we're going to end up doing is iterating over the array and then calling .announce on each element, because we know that each element being stored in the array is an instance of the class storm. And storm in itself has access to the announce method, so we can actually call .announce on each element of the array. One more thing we need to do here before we go on is to actually update the storm's index. Because if we don't update storm's index and we go to line 19 here, and let's say we actually assign it the same way, and I'll get rid of the console write line here as well. What's going to end up happening here is, since storm's index is still set to 0, it will overwrite what was stored in that position previously. So on line 14, we're actually storing the pupil's windstorm on the 0th position of the array. And on line 19, we're storing the mage's rainstorm on the 0th position of the array because storm's index is still set to 0. So we will lose this piece of data, and it will be overwritten by the mage rainstorm. So we actually want to add a new element into this array. We need to update our storm's index by increasing it by 1. So when we store it, we store the storm from the mage, we know that storm index will be now 1, and the 0th element will be used up by the pupil's rainstorm. So let's go ahead and do the same for our next 2 storms. We'll set one for the Archmage. We have our Archmage set up here. Instead of sending it up here to Archmage Rainstorm, we'll redefine that as that. Storm's index should be increased as well. And we'll do the same for the lightning storm. Storm index will increase storm's index by 1. So now that we have access to all the values from our array, we can actually just create a for loop. I'm going to use a for loop and iterate by calling I. So let's go ahead. We can call announce on all the instances of storm in this for loop. So we can create a for loop where we iterate over all the elements of our storms array, and each element in there will have access to the property .announce because each of those elements is a data type of storm. So let's go ahead and create our for loop. We'll start it with an integer I set to 0, and we'll set it to Well, we could set it to 10 or whatever, but we know the exact value of our storms index, and we don't want to go over that value. So we know that the max amount of elements that we're going to be iterating through is storms index. We're going to increase I by 1 on each iteration. Let's open up our code block. And in here, we can do what we were doing earlier. So we console write. Now, how do we access a storm? Well, we know our storms array, and we know that I is an actual number, an integer. And we know that storms index, basically this, storms 0, will be the first storm that we created and stored in that place, which is the pupil storm. Storms 1 is the one created by the mage, and then we increased it. I believe we did not increase it here, so this might cause an error. Storms index plus plus. There we go. And then the next one, 0 is the pupils, 1 is the mage, 2 will be the cast rainstorm from the archmage, and then 3 would be the lightning storm from the archmage. So we'll go like that, and then we'll call announce, because I is the storm's index himself. Let's go ahead and see if this worked. Should be printing out the same lines. We might have an error here. Oh, it seems to be working totally fine. Okay, we're able to loop and store the storms inside a storms array here. I believe, though, we are missing one storm here. 1, 2, 3, 4. Then we have to still print our rainstorm from our windstorm from the archmage, because we're inheriting that from the pupil. I think windstorm is being passed in from mage. Mage grabs that from pupil, so we should still be able to cast a windstorm from the archmage. So let's go ahead and add in our program and make sure that we can still print that out as well. So let's go ahead and add another storms index and set it to the instantiation of that. So storms index will be equal to a dot cast windstorm, and we'll increase storms index by 1. So we should still be getting all these values, except we're getting one more by Nielis Aran. So let's go ahead and save that, and hopefully that works. It seems storms index, I made a spelling mistake somewhere. Line 25, there we go. Okay, let's go ahead, save that and run it. And there we go. We are able to cast the weak windstorm. I think this should have been corrected a little bit earlier, but hopefully you guys yelled at me and corrected it yourself. Okay, let's move on to a second extension here. For a second extension, we're going to add a string origin property and a new constructor to the pupil class. The constructor should have 2 parameters, one for title and one for origin. We're going to add a similar constructor to mage and archmage. So in other words, you should be able to run this code here. Pupil P will be having an origin, basically where they're coming from. Okay, so let's go to our pupil class here. So first thing we should do is add another property here called origin. So we know it's a string. Origin, we're going to have a getter and a private setter, so we can define it within this class. Now we could just hardcode the setting of the origin here, but what if we actually have a instantiation of a pupil that doesn't have an origin? We don't want to limit someone to always have an origin. So we could have a new signature where we use a colon and we actually pass in the origin using a keyword called this. So let's set up a new constructor so that we can call both. We can create a pupil from it with an origin and one without an origin. So this will be our other constructor here where we set up title, string, and origin. And we want to grab the title from the instantiation using this. So this title will grab the title, and if there's an origin, it will set up the origin to origin, the value origin that is passed in when we create a new instance of the class pupil. So once again, this allows us to call the constructor pupil with simply a different signature. So if there's a title that we're passing in, we'll grab the title from that instantiation, and we'll also set up the origin. Otherwise, if we don't pass an origin, we'll simply be using this signature of the constructor. So we have to go to mage and do something similar here. We already have our constructor here that grabs the title from pupil. We also want a different signature. where if an origin is passed into the pupil, or the mage, I'm sorry, we can still grab it as well. So let's go ahead and create a new constructor with different signature, and we're still going to be using base to instantiate the constructor from pupil. So mage string title and string origin. Origin will be calling the constructor from the superclass using the keyword base, and we're going to be grabbing the title and the origin, and make sure you add your empty code block here. And lastly, we're going to be going to the ArcMage. So for the ArcMage, we'll do the same thing. We'll create a new constructor with a different signature. We're going to pass in the title, and we're also passing the origin, and we'll use base here with a colon, title and origin. Okay, so now we'll be able to actually pass in an actual origin to our classes. So let's go ahead and make sure things are still running. It seems there's an error on ArcMage line 11. I missed a semicolon. Here we go. Not a semicolon, but I missed code blocks here. Let's run this again. Okay, we're able to get the loop. So now that we actually are able to create instances of pupils and mages and archmages without an origin, we can set up a certain origin. So let's see exactly what they're asking. For Measle, we want him to be Ice Crown. We want Gul'dan to be Draenor. So I guess key point here is to notice that there were no errors when we didn't actually pass in an origin. So we can actually pass an origin here, and it should still be able to print out the same thing. And if you want to make sure to that you're actually passing in the mage, you can actually print it out onto the console here. We have access to the property origin from our mage, so we can actually console right line the origin, and it should be used like a method. Oh yeah, it's not a method. We can just simply pass in origin, and that should be the string that we're actually passing in. So we can see the origin for me skill is Draenor. So that seems to be working fine. Okay, awesome. So let's move on to the last extension that we're going to be writing. This will be defining an abstract class spell with essence, is strong, and caster properties, and an abstract announce method. So what is an abstract class? Well, abstract classes are classes that contain one or more abstract methods. So by that I mean an abstract class that has a method that is declared but contains no implementation. And also remember that abstract classes may not be instantiated and require subclasses to provide implementation to the abstract method. So if we actually create an abstract class for spell, we're going to set it defining certain methods here that are not going to be actually implemented. We're going to be implementing them inside another class that we're going to be passing it into. So we're going to make sure that Storm inherits from spell. So spell will have a certain kind of properties and maybe the announced method that will be passed in to the actual Storm class. So let's go ahead and create an abstract class with a keyword called abstract class spell. And in here, we're going to be setting in the certain properties. Now we want the properties to be the same. We're actually just going to change a little bit how we set the values. So let's go ahead and start with our public string essence property. We'll set a get here. And instead of setting out a private method, we're going to use protected. So whenever we want to use protected is essentially when you want your class and all derived classes to be able to access the method or variables, but you don't want these values to be public. So we can set up protected since we're inheriting. This is going to be inherited into our Storm class, and this is where we're going to be setting the values. So we'll set a getter for set a getter for is strong as well. Public bool is strong. A getter and a protected setter. And we'll do the same for our caster value, string caster. We'll set it to get and protected set. So we also want our announce method to be contained in public. So we can set up our method here, announce. Now there will be a problem here. Remember that we're essentially putting the declaration of these methods. We're not actually implementing them here. We're implementing them in Storm. But if we want to actually create method here that's going to be implemented in Storm, we have to define that it's going to be implemented in the subchild class. So the way to do this, we did it with the other inherited class from where we overrode a class. I think it was between Archmage or Mage. We actually set our Storm Castrain in Mage, and we overrode it in Archmage. We overrode it by simply using the keyword override. So in here, we're going to use kind of like the similar concept, except we're going to use our abstract keyword here. So abstract will be set to this method declaration here. And if we do this, we have to go into our Storm, and same thing we did here. We have our Mage, we set it up as virtual, which is expecting the child class to override it. We have to use our keyword override in order to make sure that we're going to be overriding this method. So let's go ahead and save this, and let's make sure that Storm is being inherited from spell. Make sure to save this and see if we have an error here. It seems that we have an error. The reason we have an error here is because we're essentially redefining the properties twice in two places. We have our spells being defining the properties here in the superclass, and in the derived class we're also defining the properties here. So we actually don't even need to set them up here in Storm because we're going to be grabbing them from the spell class. So if we go ahead and save this, we should be able to run our code as usual. And you can notice that we don't need to set the properties in Storm because we're already setting them up here. Kind of like what we did with Mage, where we used the base constructor here. So this basically concludes the whole project and our extensions. Hopefully you guys got a better idea how to use inheritance and how to pass different methods and use the base constructor to actually call the constructor from the superclass. Feel free to give it another shot and mess around with these classes and maybe add some other methods if you'd like. But thank you all for watching, and I'll see you all next time.